Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazim bin Nasruddin. Today, I will present a slideshow of mini project for a subject introduction to microprocessing system code ECE354. We go to the introduction part. Based on the equation, based on the equation given for this mini project, which is a power of 3, the assessment are designed and determined by using the instruction set, which is a multiplication. The reason why the project is using this instruction set because there is no specific instruction for a power operation in assembly language. So in this case, looping system are used to achieve the desired output of program. In multiplication, there are three types of mnemonic for multiplication, which is emul, emuls, and mul. The emul instruction handle unsigned 16-bit integer in the accumulator D and Y, while the emuls instruction handle signed 16-bit integer in the accumulator D and Y. Also, for the mul instruction, the instruction handle unsigned 8-bit integer in the accumulator A and B. Go to the next part, which is objective. For this mini project, we can determine that there has a 4 objective for this question type, which is to determine the power operation concept in assembly language. Second, to understand the process follow of assembly language instruction. Third, to understand the flowchart based on the instruction in the coding. And lastly, to understand the usage of instruction set, which is load, store, and arithmetic operation, which is multiplication. For the question part that given by the lecturer, we choose a power of 3 topic. The question is build a program to calculate power of 3 for the hex number $1A from address, for example, $1600, then save the answer at starting address at $1800, for example.
Okay, this is our flowchart for the program to calculate the power of 3. First, we define letter n with 3. N is basically the what power we want to use. So in this question, it requires us to calculate the power of 3. So we will use 3. If we want to use power of 2, we just substitute 3 with 2. If you want to calculate power of 4, just substitute 3 with 4. So for the value is what we want to calculate. The question wants us to calculate power of 3, the 1a for the power of 3. So we put the value to the 1a into the value. So instead, if you want to use something else like 707, we just substitute 1a with 07, and then we define I to one location address, which is 800. I is basically the counter for the loop, and then I will be explain later on. And then we define ans, which is answer. Ans is the answer for the calculation will be stored. The data value will be stored into ans. So in this case, we define ans into two location address, which is 801 and 802. And then we move data 1 into I. Okay, for the first loop, we will declare I equal to 1, because because I after this will be increased by 1. So the next new value, the new data value of I will be 2, and then for the next loop will be increased by also by 1, so it will be 3, and then we move data 1a into answer. So the first data value of answer will be 1a. Okay, and then we load data memory location I into B. Load data from memory location I into B. So why we need to do this? Because to compare the letter I with the letter N, we need to put I into B first, so we can use the instruction that provide in assembly language, which is compare B, CMP B, and then what value we want to compare. In this case, N. Oops, sorry, N. Yes. Okay, so that's why we need to put the data from I into B, and then we compare B with the N using this instruction. So what happens if B is not equal to N? So if B is not equal to N, it will be calculate the multiplication. If B is equal to N, if B is equal to N, which is if B is 3 and N also 3, so it's the same, yes, so it will be straight down to the end, so it will stop the program decoding. So for the first loop, so for the first loop, first loop we declare I into 1, so I will put into B, and then it will compare with the N. So for the first loop, it will be no, because I is 1, N is 3, so you will calculate the multiplication, and then it calculate the multiplication by load the A1 into D. So D for the first loop will be A1, 1A, sorry, my bad. And then Y will be answer. Answer for the first loop will be is 1A, because in this above line we declare that we define that 1A into answer, the data of 1A into answer. So the answer for the first new data is 1A. So 1A we put into Y. So Y is equal to 1A. And then we multiply the data D with Y. Why we use D and Y? Because later on we will use the instruction emule. Use when we want to calculate D with Y. So, and then the answer will be put in the ratio of Y D. So basically you will put the answer into D. Okay, and then we calculate 1A and 1A, and the answer will be 02A4. So that answer it automatically store into D, and then we grab the answer, the data value, and store that into the answer. So basically we store data from D to memory location answer. So the answer, the new data value of answer will be 0 to A4. Yeah. And then it increase the increase data value of I by 1. So the new data of I will be 2. So for the second loop, second loop. So it will be it back again to here, to the to this line. So it will be load data from memory location I into B. So it will be load the new data of I, which is 2 into B. So and then it compare again B with N. If it is B is equal to N, so B the new B will be 2, and then N is still 3. So the answer is no. So it will continue to calculate. So it will calculate again just like before. 1A into D. D is still 1A, and then dy will be the answer from the previous. So in this case it will be 0 to A4. The answer from the first loop will be stored into the Y. And then you multiply the data, and then the answer will be 4488. And then the answer of that multiplication will be stored into the ends. So the new data value of ends will be 4488, and then it increase I again by 1. So the new I 2 plus 1 will be 3, and then it up again. So and then it compare again. Is it I is equal to N? So in this case I is 3, N also is 3. So the answer will be yes. So it will straight down to the end. So they basically our flowchart to calculate the power of 3. Here is our coding that based from the flowchart. Okay, as you can see here, we state that N is equal to 3 and value is equal to 1A. So N, as I have mentioned earlier, N is what power we want to use, power, and value is what value we want to click, value to calculate. Yeah. And then okay, so for the next line is this instruction is basically we want to define that the slot of 800 is belong to I, because I is stay here one slot. So I will be have one slot, so it will be 800. So the address of I will be 800. And then for answer, it want 2 slot, because we say here 2 slot. So because of I have been 800, so it will take the next slot, which is 801 and 802. So answer will be 801, 802. And then for this line, it move data value of 1 into I. It load 1 into I, and then it load value, which is 1A, into answer. And then to compare, we need to compare I with M, and we need to load the data of I into B so that we can compare with N by using this instruction CMPB. And then what this BEQ done line function is basically when the the value of B is equal to N. If it's yes, it will straight to done. which is here. So it will straight down to n and then stop the program. If no, it will continue the next line, which is to calculate the multiplication of the power of 3, the multiplication. So for the first loop it will be no, and then it will be straight down here to calculate multiplication. So to calculate the multiplication, we need to load the value into D, the value which is 1a into D, and then the answer into Y, just like the flowchart. And then we use emule because we use D and Y. So we emule to multiply those two data, and then that data will be stored. Data that automatically stored in D will be stored into the answer. So we use std answer, and then we increase I by 1 by using this instruction inci. And then in order to do the loop, we need to put this instruction, which is bra loop. So it will be back up into this line again, and then it repeat again, and then up again until the b is equal to n, and then it will stop here. And if it's the same, it will be down here and stop the program. So that's basically the our coding to calculate the power of 3.
So for this slide, we are going to discuss about the simulation result of coding based on ECE354 software. So from the coding that we have built in the software mini IDE, we need to insert the coding into this ECE354 simulator by load the file into the simulator. So based on this picture, for the first picture is the process, is a tell about the process to load or to make the 1a as hex number data value. So from this picture we can observe the result based on the CPU register and also the memory display here. CPU register shows that the data value that hold by incremental A is at 0, 0, 0, 0, and the data value that hold by incremental D is 1A. So so the data we go into the memory display here. We show that address 800 is start particular by address by 800, the address 800. So right now we are going to look at the address 800 here. This shown the data value hold by this address is 01, and the data value at the memory location 801 is 00, and memory location 802 have a data value 1A. So from this data value that in the memory location 800 is 01, because the V initialized that indicate I is equal to 1. So that's why that's why the address 800 is equal to 1, because I equal to because the data value that initialized by I will load or store in address 800. So for the picture 2, this is this picture is tell about the process of multiplication of the hex number 1A and multiply with 1A. So the result from this multiplication process is shown that the result is data value of 0 to A4. So from this result, it shows that incremental A also have hold the data value of 00, and accumulator B was hold the data value by A. This accumulator only consists 8-bit integer. So in the question of power 3, they're about to uh, save the answer in a 16-bit integer. So we need to combine the both of accumulator A and B into the accumulator D to consist the 16-bit integer. It seems like the data value that hold by both accumulator, but we transfer it into the accumulator D. So the accumulator D is a 001A. So this instruction set, which is the include is the multiplication process of 16-bit unsigned. So the process of 1A multiplied with 1A is equal to 0 to A4, which means it was loaded in the accumulator 1. So from the memory display, it is shown that particular by address 800, it shown that address 801 was hold the data value 02, and address 802 was hold data value A4, which means that same value in accumulator 1. From this address 800, this data value is changed from 01 to 02 because this data value was increased 1, because the instruction we made from the coding, which is increment 1 when I is not equal to integer n. When I is not when I is equal to n, so I will be increased 1. This is the last picture for the simulation result of coding based on ECE354 software. So this picture is the tell about the process multiplication of 1A multiplied with 1A multiplied with 1A. The result given from this process is $44A8. So we going to the simulation. Based on the CPU register, the accumulator A right now was hold the data value 44, and accumulator B right now was hold the value data value which is A8. So this accumulator A and B was combined into the accumulator D to consist 16-bit integer. So going to the memory display here, the address 800 and 801 have all the data value 44, which means it saves the data value at accumulator A, and this 802 have all the A8 data value, which means that saves at the data value in accumulator B. So this address 800 must have a data value 03. This means that instruction was satisfied, could indicate I equal to n. So the n we has initialized n equal to 3. So I here is equal to 3 because the I was increased, and it will stop until I and n is have the same value. So for the last video is me, the program the program have been done, and the result power of S number is $44 A8. So the next, we are going to the conclusion. So the first point for the conclusion, a power of 3 program has been determined, then could have come out with their correctly final answer. This will be proved by our recent result in the simulator, which means that the power of 3 of 1A is equal to 44A8 as number. So next, the process of power of 3 operation must be changed in the shape of multiplication operation, because they no have a specific power operation in the same English. So we need to change the process power of 3 by using the multiplication operation, which is 1A multiply with 1A multiply with 1A is equal to the 1A power of 3. So the type of binomial that used in the multiplication instruction set was emule that function to multiply the 16-bit number assigned. Because the question will ask to save the answer in 16-bit numbers assigned. So the last one, the flow chart. The flow chart function is to explain and summarize the process of coding. The flow chart that we have designed before is also have been construct that consists as start and end symbols, 10 operation symbols, and 1 decision symbols. That means we have done this mini project smoothly and successfully. So we we have done our mini project presentation about title of power of 3 for his assessment in the subjects introduction of microprocessor system. So that's all from us. Thank you.